mass volume relationships include particle density. We have what we call the dry bulk density and the total or wet bulk density, the dry specific volume, the porosity, and void ratio. So earlier, I said that soil is a three-phase dispersed system. So three-phase dispersed system because it composed of three phases, the solid, liquid, and the gas, that is dispersed within a medium. So that's a soil. So that's why soil is called the three-phase dispersed system. So how come that the soil composed of three phase? So as we all know, soil is an interface of four earth systems. We have what we call the hydrosphere, the lithosphere, the biosphere, and the atmosphere. So the hydrosphere concludes the water, the lithosphere, the bedrock and the solid materials, the crust. The biosphere includes the organisms, the living organisms, the micro and macroorganisms, and the atmosphere, which includes the climate or weather. So that when that four interacts with each other, so their interface is soil. Doon nabubuo yung soil natin. So that's how we have a three-phase dispersed system. The interaction of these systems contribute to the four major components of soil. We have soil water or solution. So somehow, ginagamit natin yung soil water, pero in reality, it's actually a solution because we all know that the soil the water in the soil is not purely water. It composed of dissolved salts or nutrients. So that's why it is called solution. Then also mineral matter. So mineral matter, specifically, we have the inorganic materials, the primary and secondary minerals. Then we have the organic matter, specifically the humus, and also the air. So in soil density, porosity, and other mass volume relationship, we are dealing with their masses and their volume. Yung mass and volume ng mga components na ito. So soil is a three-phase dispersed system. It is composed of solid materials, the liquid and gas that are scattered within the soil system. So for you to understand, dapat you are very familiar with this illustration, with this schematic diagram. So ideally, soil is, we all know that soil is 50% solid and 50% pore space, right? So ito yung 50% pore space na yon, which is the air and water, and yung 50% solid na yon, which is the mineral matter and organic matter. So hinati na lang sa pagkuha ng density, porosity, and other mass volume relationships, we are dealing with the air, water, and solid particles of soil. So here on the mass part, we have the mass of air, which is commonly void kasi wala namang timbang yung air. It's very low. That can be deduct or can be hindi na napapansin. So that's the mass of air. So we also have the mass of water. We have the mass of solid and the mass total. So the mass total is the combination of mass of air, mass of water, and mass of solid. Then on the other part, we have the volume, which is composed of the volume of air. So volume of air, it is ideally it is 25%. Then volume of water, which is also ideally 25%. Then the combination of volume of air and volume of water is actually the volume of pore space. Okay. Then we have the volume of solid. Then the volume of pore space plus the volume of solid is equal to the volume total. So dapat alam natin ito. Okay. So this is the schematic diagram of the soil as a three-phase system. Ito yung mga pagkukuha natin ng value para dun sa bulk density natin and also particle density and also porosity. So, what are the importance of soil mass volume parameters? First is it is an indicator of low soil porosity and soil compaction. Specifically yung bulk density natin. Kapag yung bulk density natin ay tumataas, so if the bulk density is increasing, there is a soil compaction na nagaganap. Also, it has low soil porosity. Kasi di ba yung bulk density is ito yung tinginan kung yung bang soil natin ay compacted or hindi. Okay, because sa bulk density ang tinitignan natin doon is yung volume total. Next is it influence available water capacity. Of course, because the pore spaces is the responsible for the storage of water. Once na yung density natin, bulk density natin ay mataas, ibig sabihin compacted, wala nang kakaunti na yung water na pwedeng maging available doon. Then root growth also, movement of air and water or yung permeability, tinatawag natin, reduce crop yields and vegetative cover that further enhance soil erosion. Although this is figure or illustration is also related to soil structure, as you can see here, this is a good soil structure. Yung unang picture kasi yung roots niya it really expands. Walang nagaganap na root impedance. Here in the other one, lalo na dito sa other, may layer siyang pinaka-dense. Ibig sabihin wala na siyang pore spaces. Dense na yung lupa. So mayroon nare-restrict doon yung root growth. So this is not good for crops. So soil mass volume parameters, we have particle density, dry bulk density, total or wet bulk density, dry specific volume, porosity, and void ratio. So commonly, the difference between dry bulk density and total or wet bulk density is that sa dry bulk density, yung mass lang ng solid ang kinukuha natin. Wherein, dito sa total or wet bulk density, yung total mass yung ginagamit natin. So makikita natin mamaya yung difference nila. So first is the particle density. Okay, so it is used with this symbol S or karaniwan PD. Yun na lang ginagamit niya for particle density. PD. So it is mass per unit volume of soil particles not including the pore space. So ito yung pinaka-keyword sa particle density. It does not include the pore spaces. So we are dealing here with only solid parts. Okay? The mass of solid and the volume of solid. Kaya pag kukunin natin yung particle density, so particle density is actually equal to the mass of solid over the volume of solid. So this is also called as the density of solid because we are dealing here with only solids. Okay? Yung soil natin, it composed of air and solid particles. So in particle density, we are dealing with the density of only solid. The particle density of post-mineral soil vary from 2.6 to 2.75. So ito yung average particle density natin. So pag sa board exam ka rin yung matatanong, what's the average particle density of the soil? So it is 2.65 or 2.66 or 2.6 to 2.75. That's the average particle density of the soil. But because organic matter is lighter than the soil, the particle density of organic matter varies only from 1.2 to 1.7 grams per cubic centimeter. So bear this in mind that the unit of density is mass over volume or grams over cubic centimeter. So this is the particle density. So mass of solid over volume of solid. So mass of solid is this one, yung timbang lang nitong solid. So mass of solid is ito. This is the mass of solid. Then the volume of solid is this one. Ito lang din siya. Okay? So yung solid lang talaga tayo nagpo-focus pagdating sa particle density. So particle density value tends to become higher if large amounts of heavy minerals such as magnetite, limonite, and hematite in the soil, and tends to decrease with an increase in organic matter. So yung particle density is nakadepende sa minerals na meron yung soil natin. Okay? Because these are the solid particles. So karaniwan, pagka rich in organic matter, yung soil natin, it has low particle density. But if it contains heavy minerals such as magnetite, limonite, and hematite, we have a high particle density. So these are the average particle density of the different soil constituent. As you can see, humus has a particle density of 1.3 to 1.5. So yung particle ng humus lang tinitignan dito. So 1.3 to 1.5. We have the clay minerals, which is 2.2 to 2.6. Orthoclase, 2.5 to 2.6. Quartz, 2.5 to 2.8. Calcite, 2.6 to 2.8. And those are heavy minerals, which is pyrite, 4.9 to 5.2. And hematite, which is 4.9 to 5.2. So it depends on the mineral composition of the soil. So if you experience determining the particle density of the soil, so it can be estimated using pictometer method. Okay, are you familiar with pictometer method? So I am not pictometer method. You can look for YouTube. Yun talagang proseso ng pictometer method. But yung principles ng pictometer method is that using volumetric flask, yung soil natin ay, di ba, yung soil natin, yung volume niya is composed of pore spaces. May mga hangin yon yung lupa natin. So ang kailangan kasi natin is yung volume lang ng solid. Madali lang ma-measure yung mass ng solid kasi i-oven mo lang yung soil, makukuha na natin yung mass ng solid. Pero yung volume ng solid mahirap ma-measure kasi may pore spaces yung lupa. So ang pictometer method is that using volumetric flask, okay, yung lupa natin ay ilalagay natin doon sa volumetric flask kasama ng water. Then yung madadagdag na volume doon sa volumetric flask is yun yung volume ng solid. Okay, that's how we measure the volume of solid. Kasi kailangan mapuno yung mga pore spaces, dapat mapuno ng water na pagdidilutan natin para yung solid lang yung ma-measure natin. Okay, do you naiintindihan yun? Yung pictometer method? Diba, ito yung ginawa natin sa laboratory. I think ginawa niyo din yun. Yun yung titimbangin doon yung volumetric flask, then volumetric flask with water, volumetric flask with water and soil. Then ina-minus lang para makuha doon yung mass, then ma-minus din para makuha doon yung volume. Gamit yung density ng water at saka ng soil. I think naintindihan niyo naman yung pictometer method. Yun yung pinaka-essence ng pictometer method. Okay? So now we are with dry bulk density and wet or total bulk density. So yung dry bulk density, it is the mass of solid over total volume. Okay? Pag wet bulk density, ito naman yung total mass over total volume. So karaniwan, we are using the dry bulk density. Karaniwan, oven dry muna natin yung lupa bago natin kunin yung bulk density. Tinatanggal na natin yung wet part or yung water ng soil bago natin kunin yung bulk density. Okay? So this is mass per unit volume of soil including the pore space. So ang keyword dito sa bulk density is that it includes the pore spaces. Yung sa particle density, we are only dealing there with solid. Okay? With the volume of solid. Wherein sa bulk density, included na doon yung pore space. Kaya total volume na yung ginagamit natin. So, the bulk density of uncultivated soil varies from 1.0 to 1.6 grams per cubic centimeter, or in average, 1.33 grams per cubic centimeter. Yun yung average bulk density ng lupa natin, 1.33. Okay? Napansin nyo, kalahati, yung average particle density natin is 2.66. Yung average bulk density natin is 1.33. So, kalahati ng particle density, yung value ng particle density yung bulk density. Why? Kasi included na dito yung pore spaces sa bulk density. Dinivide na natin siya sa total volume, which is, di ba, ideally 50% ay pore spaces sa lupa at 50% solid. Kaya kung iisipin nyo, pag 2.66 ang particle density natin at ang bulk density natin ay 1.33, ang porosity natin is 50%. Okay? So makikita mo na agad yung pore spaces dun sa pagka meron kang bulk density at particle density. So bulk density increases with compaction. So habang nakakompact yung lupa mo, ibig sabihin na nawawala doon yung pore space. So, ang tendency nun, i-increase yung value ng bulk density. Kasi yung volume mo ay liliit. Kasi yung pore spaces, lumiliit. Okay? So, it helps in estimating the weight of soils per unit area. Yung sa ating bulk density. It is also called apparent density kasi ito yung karaniwang ginagamit sa soil. Yung bulk density. Because it really dictates other properties. So how we determine bulk density of the soil? We use core method and paraffin clad method. Sa core method, so gagamit lang tayo ng core so yung core method, natatandaan nyo yung gumamit tayo ng core. So like for example, ito yung core. So yan, ilulubog natin sa soil. Then, kukunin natin yung volume nito. Okay, yung volume ng cylinder. So, dahil total volume naman yung sa, dahil total volume, ginagamit natin sa pagkuha ng bulk density, yung total volume nito yung kukunin natin. So, that's the total volume. Yung volume ng cylinder. Then, after mong i-oven dry yan, yung laman yan, yung laman ng lupa, then that's the mass of solid. Makukuha na natin yung bulk density. So that's the core method. Okay? Yung paraffin clad method naman, pag wala tayong core sampler, kukuha tayo ng clad. So like for example, itong clad na to, then isasubmerge natin siya sa paraffin. Okay? Yun yung tinulaw na kandila. So pag kinote natin yan ng paraffin, yung tubig hindi na papasok sa soil kasi may paraffin na na-coat na siya. So titimbangin natin ngayon yung clad natin na nabalot ng paraffin underwater. So kung naaalala nyo yung ginawa natin sa paraffin clad method, that's how we determine the weight of the soil. That's the mass of the soil. That's the mass of the soil. Okay? Then, over the total volume. Yung volume nitong mismong clad na to. Dahil na-submerge na yan sa tubig, syempre yung madadagdag na volume sa water, sa cylinder, yun yung volume nung clad. So, yun yung principle ng paraffin clad method. So, also you can look for videos regarding the complete method on how core method and paraffin clad method is done. So you can see here, bulk density, which is the most commonly used. So it is mass of solid over volume total. Okay. So mass of solid, so ito yung mass of solid. So ito, then over volume total. So volume total is lahatan na siya. So yan yung volume total. So yan yung pagkuha ng dry bulk density. Okay? Then in terms of wet or total bulk density is mass total. So the mass of this, kasama yung tubig, hindi na inoven dry yung sample, that's the mass total, over the volume total. So that's volume total. Lahat din yan. Okay? So that's the wet or total bulk density. Karaniwan, if you are asked with bulk density, then may given doon na dry soil sample, so you can just use it as the mass of solid. So that's the dry bulk density. Ito yung karaniwang hinahanap, yung dry bulk density. Pero may mga given naman pagka binigay na specific na total bulk density or wet bulk density yung pinapahanap, so the mass total will be used. Okay? So these are the range of bulk density. You can see here, yung pit natin, because it contains of high organic matter, so it is very loose. So it is only 0.1 bulk megagrams per meter cube or grams per centimeter squared. So megagrams per meter cube is also equal to grams per centimeter squared, a cube. So compost is also light, low bulk density. Then we have the cultivated clay and silt loam. So commonly, ito na yung 1.33, ito na yung average na bulk density ng lupa natin. So after that, ng 1.33 pataas, so karaniwan ito na yung nahihirapan na mag-penetrate yung roots natin. So root penetration inhibited in moist soil. Then we have the frangipans, which is very dense. So mataas na yung bulk density pag frangipans. Ranges from 1.6 to 2.1. So ito na yung compacted soils natin. Okay, then the concrete and the particle density of quartz minerals, which is 2.6 to 2.7. So it is the average particle density na. To differentiate particle and bulk density, so here, consider 4 blocks of solid rock. So ito yung 4 blocks, it is arranged no pore spaces. So that's the total volume. Volume of solid lang. Okay? So particle density is, for example, the weight of these 4 blocks is 21.6 divided by the volume, which is 8. So the particle density, which is 2.7 grams per cubic centimeter. Cubic centimeter. So that's the particle density, no pore space. So bulk density, consider a cylinder. So the volume of cylinder is pi r squared height. So the radius is 3 cm and the height is 2.5 cm. So substitute the value of pi, which is 3.14, multiplied by the radius squared times the height. So that's the total volume, 17.7 centimeter cube. Then the weight is 21.6, which is similar to the particle density. So the mass, which is 21.6 over the volume, which is 17.7, so it will yield to 1.22 grams per cubic centimeter. Okay, if you compute what's the percentage pore space, it is 55% and the solid is only 45%. So that's the difference. So the bulk density is lower compared to value compared to particle density kasi kasama dito sa bulk density yung pore spaces. Yan. I hope you nare-retain naman yung the difference between particle and bulk density. So another sample. So in the field, 1 cubic meter of certain soil appears as, so yan. Yan yung soil in 1 cubic centimeter. Okay, it composed of solid and pore spaces. To calculate bulk density of soil, volume is equal to 1 cubic meter, where the weight is 1 megagrams. So solid only. So weight over the volume, 1.33. So kasama dito yung volume ng mga pore space, itong mga white na yon. Then in terms of particle density, kailangan matanggal doon yung volume ng pore space. Kasi we are dealing here with only the volume of solid. So ideally, 50% ng volume nito ay pore space. So 0.5 meter cube na lang yung kanyang volume. So that's 1.3 megagrams over 0.5 is equal to 2.66 megagrams per cubic meter. So don't be wag malito, yung megagrams per cubic meter is also equal to grams per cubic centimeter. Then we have the dry specific volume. It is total volume of soil per unit mass of dry soil. So it is actually the reciprocal of dry bulk density. So 1 over the bulk density or volume total over the mass of solid. Okay, reciprocal of dry bulk density is our dry specific volume. So this is volume over mass. So the total volume, so volume nito, so the dry specific volume is the total volume, so ito, which is volume nitong itong tatlo, over the mass of solid, which is the mass of solid ay ito lang. So that's the dry specific volume. We have the porosity. So porosity, it refers to the percentage of soil volume which is occupied by pore spaces. It is commonly expressed in percentage. So percent pore space is equal to 100 minus bulk density over particle density times 100. Okay, yun yung formula natin sa pore space. So pag meron na tayong bulk density at particle density, we can easily compute for pore space. So if you have your calculator, try to solve this. So yung average bulk density natin is 1.33. Okay? 1.33. Then yung bulk density natin. Then yung particle density natin, average is 2, sorry. Yan, 6 yan. 2.66. So, calculate the percent pore space. So, 1.33 over 2.66 times 100 is equal to 50. Diba? So, 100 minus 50 is actually 50%. So, kung ideally, ang particle density natin ay 1.33 at ideally din, ang particle density natin ay 2.66. So tama na ang pore spaces natin is actually 50%. Okay? Ideally lang yan. So, given yan. Yung mga value na yan ay pwede pa rin magbago. So, porosity varies with texture, shape of individual particles, soil structure, amount of organic matter, and degree of compaction. So, it can measure the volume fraction of the soil, but it cannot show the pore distribution of the soil. So, pwede nating ma-measure yung amount ng pore spaces, pero hindi natin makikita kung paano yung distribution ng pore spaces sa soil na yun. That's the limitation of computing the porosity of the soil. If concentrated ba yung pore space niya or dispersed. So that cannot be identified in using this computation. So porosity can also be uses the symbol F. Okay, so it can also be computed using volume of pore spaces over volume total. If kung pinapahanap yung porosity, then it is not on percentage basis, pwede nyo magamit yung volume unit ng pore space. So volume of pore space, so eto, volume nito ng air and water over volume total. So over volume total, that's the porosity. So in decimal unit, kapag hindi percentage, you can use this formula. 1 minus bulk density over particle density. So that's also equal. So 1.33, for example, over 2.66 is 0.5. So 1 minus 0.5 is 0.5. So 0.5 yung kanyang pore space. Or you can also use this formula, volume total minus volume of solid over volume of solid plus volume of water plus volume of air. So that's how you compute porosity. So there are lots of formula to be used in calculating the bulk density, the porosity, the particle density of the soil. Okay, you just need to understand kung ano ba dun yung volume ng solid, ng volume ng air, at mass ng solid, mass ng air, mass ng water, mass total, para ma-compute yung mga tanong. So in board exam, I think natatandaan ko may natanong doon about if the particle density is 2.66 and the bulk density is 1.33, what is the percent pore space? So very simple, 50%. Kasi I know that the bulk density divided by particle density is 0.5 times 100, so 50%. So ganoon lang yung mga computations dun sa board exam, I think, na na-experience ko. Okay? Ang mahalaga doon is yung alam nyo yung principle at pagkuha ng density ng lupa. At alam nyo yung difference between particle and bulk density. And also porosity. Then a type of pores, we have the transmission pores, also called macropores. So etong mga macropores natin, ito yung sinabi ko kanina, ito yung karaniwang naglalaman ng air content sa lupa. Air at saka dito nagpe-penetrate yung roots. Pag sinabi naman natin storage pores or also called micropores, dito naman nai-store yung water sa micropores. Then residual pores, these are very small pores between clay particles. So ito yung karaniwang naglalaman ng mga water films. So yung na hindi na-absorb ng halaman. Yung every soil particle kasi meron silang may mga naka-attract doon na water molecules. So kahit na hindi matutuyo at matutuyo yung lupa dahil it is very attract in the particle of the soil. So you will learn that, I think, tomorrow on the moisture property of the soil, which is merong yung tinatawag nating hygroscopic water. So ito yun, yung sa residual pores na tinatawag. So you can read the others. I think if I can give you the copy of the PowerPoint. So micropores, ito yung sinasabi natin kanina. So this again, within the aggregates. Ito yung isang aggregate. So yung mga pagitan dyan, that's the micropores. Wherein the macropores is, ito na yung kanina, andito yung mga micropores. Yung mga between soil aggregates naman, andyan yung macropores. Okay. So yan. Micropores, so that's the micropores. Then between that are the macropores. So as you can see here, makikita natin the relationship of depth of the soil and their bulk density ng harvested and undisturbed volcanic ash soil na ginamit for timber. As you can see here, pag undisturbed yung lupa natin, mas mababa yung bulk density. Ibig sabihin hindi compacted yung lupa. So undisturbed, ayan, mas mababa. Sa depth sa surface soil, makikita natin napakababa yung bulk density, ibig sabihin hindi siya compacted. Hanggang sa syempre dito sa below, which is 30 to 40 centimeter, medyo compacted na kasi hindi naman nagagalaw yung layer na yon, which is similar to harvested. Pag harvested or ibig sabihin ginamitan ng other or tinanggal doon yung puno, this the timber production, nagiging compact yung lupa natin. So yan, it ranges from 0.8 to 1. Yan yung bulk density ng lupa natin. So kaya di ba sabi ko kanina natin sa conservation, it is very prominent na ginagamit yung minimum or zero tillage or yung undisturbed yung lupa natin. So void ratio, what is void ratio? So void ratio is the relative proportion of the voids to that of the solid. So we measure here the volume of the voids or the pore space over the volume of solid. So one of the importance of this void ratio is yung pag nag-establish ka ng ponds, okay, kasi yung dapat more on solid particles lang yung surface ng ponds para hindi nagpe-penetrate or nadi-drain yung tubig. Okay, that's the importance of void ratio. Generally, preferred index in soil engineering and mechanics, measured by dividing the sum of volume of air and water to the volume of soil. High void ratio means soil is loose. So, mas mababa dapat yung void ratio para mas compacted. Okay? The more na mataas yung void ratio, loose yung soil mo. So, how it is computed? Void ratio is equal to the volume of air plus volume of water. So, this will be the volume of pore space. Also, so volume of pore space is volume of air and water. So, ito yun. Or the volume of solid over the volume of solid. So, volume of solid is ito lang. So, that's the void ratio. Or the volume of solid can also be computed volume total minus volume of pore space. So, that's the void ratio. Question so far? Hello? Gising pa ba kayo?
Yes po.
Okay. So we have here a sample problem. Sample of moist soil having a wet mass of 154 grams and a volume of 79 cubic centimeter was dried in an oven and found to have a dry mass of 126 grams. Assuming that the volume of solid is 48 centimeter cube and the volume of water is 20 centimeter cube, calculate the particle density, dry bulk density, wet bulk density, dry specific volume, porosity, and void ratio of the soil. So first things first to do is to write the given numbers. Okay, the given value. So meron tayo wet mass or mass of solid plus water. So we have 154 grams. Then meron din tayong volume, which is total volume na 79 cubic centimeter. Then meron din tayong mass of solid, which is 126 grams kasi dry mass na yon, nawala na yung mass ng water. So assuming that the volume of solid is 49 cubic centimeters, so meron din tayong volume of solid. Then the volume of water, which is 20 cubic centimeters, so meron din tayong volume of water. So mako-compute na natin itong mga given, itong mga hinahanap. Okay? So gamit yung mga other given, we can actually derive other given numbers or other mass or volume, other mass and volume parameters. So ito yung mass of solid natin kanina, di ba? 126 grams. Then yung mass of water, makukuha na natin kasi meron tayong mass total at mass of solid. So mass of water is equal to mass of total minus mass of solid, which is 154 grams minus 126 grams. So mass of water now is 28 grams. Then the volume of solid is given. The volume of water is also given. The volume total is also given. Now we can determine the volume of air, which is volume total minus the volume of solid plus volume of water. So substitute, we have 11 cubic centimeter. Then the volume of pore space is simply the volume of air plus volume of water. So that will be 11 plus 20, we have 31 cubic centimeter. So now that we have this given data, we can now compute with the following parameters. So again, particle density is mass of solid over volume of solid. So 126 divided by 48 is equal to 2.625 grams per cubic centimeter. So dapat maging mapagmatsyag din kayo. Pag alam niyo na agad yung value na sagot, magsasagot na agad kayo sa answer sheet nyo. Huwag muna, tignan nyo din yung unit. So yung unit ng density natin is gram per cubic centimeter. Baka mamaya may same value na choices doon, pero ang unit is gram per cube per centimeter squared. Or 2 lang yung nakalagay doon. Na mali na kayo, kailangan nyo nang magbura. Yun yung iniiwasan natin sa board exam, yung mag-erasure. Okay? So wet bulk density is mass total over volume total. So we have 1.948. Then we have the porosity, which is volume of pore space over volume total, which is 0.392 or 39.2%. Then dry bulk density, we have mass of solid over volume total, which is 126 over 79, which is 1.595 grams per cubic centimeter. Then dry specific volume, we have 0.6, we have volume total over mass of solid. So that will be 79 divided by 126. So that will be 0.6 centimeter cube per gram. Then the void ratio, which is volume of air plus volume of water over volume of solid, which is 11 centimeter cube plus 20 centimeter cube divided by 48 centimeter cube. So that will be 0.64 6. Okay? So that will be the problem solving. Now, ito na yung do it yourself. I want you to do it yourself. I will give you 10 minutes or 5 minutes. I-chat in nyo lang yung sagot nyo sa number 1. I-chat sa chat box na lang. I-type in nyo yung sagot nyo. So, calculate the weight of 1 hectare farrow slice to a depth of 15 centimeter if the soil bulk density is 1.4 grams per cubic centimeter. What is the percentage porosity if the particle density is 2.65 grams per cc? Then number 2, pressed soil sample weighs 300 grams and has a volume of 150 cubic centimeter. If the oven dry weight is 200 grams, what is the bulk density? What is the particle density if 40% of the total volume is occupied by pore space? So, yan yung number 1 and then yung number 2. So, I will wait 5 minutes for your answer on the chat box. Then we can solve it together. After, I think 5 minutes or after na may magsagot dito sa chat box. Hello? So yan yung porosity. Yung porosity can be simply computed bulk density over particle density. But do you compute for the weight of 1 hectare paro slice? So wait, I'm trying to share another screen. Can you see now my screen?
Yes po, sir.
So let's try to compute. So the question is calculate the weight of The question is calculate the weight of 1 hectare farrow slice to a depth of 15 centimeter if the soil is bulk density is 1.4 grams per cc. So you don't need to compute the bulk density, it's already given. What is the percentage porosity if the bulk density, particle density is 2.65 grams per cc? So ang una nating pwedeng hanapin is yung porosity madali na lang, right? Yung weight ng 1 hectare farrow slice. So we all know that 1 hectare is equal to 10,000 meter square. Tama? So dito actually na-estimate, di ba, we have a conversion factor in soil science that there is a 2 million kilogram of soil per hectare. So without even knowing gano'n yung depth nun, di ba? Gano'n kalalim yung depth ng 2 million na yon. So here, we can actually estimate for the kilogram of the soil using the bulk density and also the depth. Okay? Another given is 50 centimeter yung depth. So depth is 50 centimeter. 15 centimeter. Right? So para maging volume yung ating 1 hectare, so we need to multiply the size, the area, which is 10,000 meters squared, multiplied by the depth, which is 15 centimeter. So of course, we need to convert the unit to become similar. Tama? So 15 centimeter is also equal to how many meters? So you can turn on your mic para magkanigan tayo, para interactive itong computation natin. This will actually help you in critical thinking pagdating sa computation. Kasi dapat yung mga computation doon, minsan nagbibigay sila ng mga data na hindi mo naman kailangan gamitin. So you need to analyze the situation or yung problem set. Okay? So, 15 centimeter is actually 0.15 meter. Tama ba? Then, pwede na natin i-multiply 10,000 meters square multiply by 0.15 meter is actually ilan? Ating calculator. It's actually
1,500.
1,500 ba or 15? 15,000.
1,500 po naman siya.
10,000 multiplied by 0.15 is 1,500. So meter cube. So that's now the total, the volume. Now, another given is bulk density, which is 1.4 grams. So 1.4 grams per cubic centimeter. So ilan yung timbang ng soil natin kapag ang area natin is 1,500 meter cube? So 1.4 grams is also equal to, so para mas madali, convert natin into kilogram at saka into meter cube. Tama? So that will equal to 1,400 kilogram per meter cube. Tama ba?
Yes po, sir.
So yun. So basta kasi 1,000 per 1,000 grams may 1 kilogram, then per 1 centimeter may per 1 meter may 100 centimeter. Doon nakuha yun. Okay? So using this data and this data, we can now estimate the weight of 1 hectare. So to cancel out the meter cube, so we need to multiply 1,400 kilogram per meter cube multiply by 1,500 meter cube. So cancel out. So ilang kilo yung isang hektarya natin? So that will be 2,100,000 kilogram. So yan na yung kilo ng isang hektaryang lupa. So now, alam niyo na kung saan nakuha yung 2 million kilogram. Tama? Naintindihan? Questions? Feel free to ask question. It's already 11:50. I think we will be extending around 5 to 10 minutes kasi may another Mentimeter pa na isa. Okay na yan? Move na tayo sa another problem. Now, we can now compute for the another problem, which is yung hinahanap na yung percentage porosity. So porosity is equal to, sabi natin kanina, 100 minus bulk density over particle density times 100. So 100 minus bulk density, which is 1.4 grams per cc, over particle density, which is 2.65 grams per cc, times 100. So ilan ang porosity natin? 1.4 divided by 2.65.
1.53 po siya.
1.4 divided by 2.65 is
0.5283.
0.5283.
83.
So times 100 yan. So 52.83. Tama? So 100 now minus 52.83 is equal to
47.17.
47.17%. So that's now the percent porosity.